Hey, what's up, guys? Okay, so here we go. Starting early today for once. Trying to get back in the saddle here with coding. My batteries on my timer are basically dead. Got off work early this morning. Went in at 4:40. Got off like basically 8:40, roughly 8:30. So we're gonna try to get at least an hour or two in early, and I'm probably gonna do some more later because peak season is over. We're not driving. I'm not driving rather. I'm a cover driver. I only drive if, like 3 people are sick, call in whatever, which is pretty rare, or if it's during peak season. So anyway, we got the penguin mix rolling. I drank a good bit of coffee this morning, so I'm caffeined up. There's a bird pecking on my yes, a bird was pecking on the window unit in my room outside the window at like 3:30 in the morning. So I had to get up at like 4:10, but I actually woke up at 3:30 because there was a bird pecking on my window unit at 3:30. So I lost 40 minutes of sleep. It is what it is, right? Bird's gonna peck. Bird's gonna peck, dog. Can't do nothing about that. Never had that happen before, but I guess there's a first for everything. Hopefully, that was the last time that will ever happen. So we're starting at 9:44. 9:44, guys, to be precise. Let's be precise here. Let's be on point. Okay, so first of all, check extensions. Extensions are good. No restarts necessary. There would be a little like blue circle with the number if that was required. So we're good on that point. What's next? Okay, so first let's go ahead and run a little play test, which I don't really need to do this because I know I didn't make any changes, but it's really just like it's really just good practice to do it. It's wise to do it every time. So although I know this playthrough is going to be successful, well, I don't know that there could be a intermittent bug that is hidden within the depths of the code base. But I don't want to toot my own horn or anything, but you know, I got pretty good at this shit. Rather, I spent like a year debugging it. If there's any bugs left, they're hidden really good. There's a few bugs. There's the score. It's the score calculation is bugged, and that's like easy. I'm not even worried about that. That's like that's elementary, dog. But we don't ever try to discard from the we don't try to draw from the discard pile. So I'm going to see how that works out. So it says we cannot draw the discard pile whenever the face-up discard is a wild card, red 3, or a black 3. Ah, this is true. Okay. So we had to draw from the stack, which it automatically took care of. And that is so loud in my ears. Rat! Like, shots fired. Bang, bang, bang. Okay. We have some attempted melds that are not going to work. Those are going to get put away. We're going to use our wild card. We're going to say yes. We're going to add to the aces because aces are high. They're worth 20 points apiece in this game, which is Canasta if you don't know. It's like the greatest card game ever created. And see, that was bugged right there. That was the score. Technically, we had 60 points there, so that should have qualified for a successful meld because 60 is the minimum requirement. But because it's bugged, it actually calculates like all the cards in the hand, and it like counts them as negative. So it's bugged. But anyway, so that worked, except for the bugged part. We're gonna discard our. We'll get rid of the 4s. I don't like 4s. I just don't like them. I don't like the number, the shape of a 4 when it's drawn like that gives me anxiety. I don't like it. It's too. I just don't like it. Okay, so now it's the other player's turn, and we are online. If you didn't know. Sorry, but you don't have any matches in your card in your hand to the face-up discard, so we can't draw. It looks as if you were unable to draw a discard pile after attempting all the possible methods. You will draw from the stock instead, unless it is the stock. The stock? Is that really what we call it? Stock? I don't like that. I don't like the name. So we're Delta 4, and we're gonna get rid of it because I don't like 4s. I forgot to make a play attempt, but I'm just trying something new because I usually do the same thing every time, which is draw from the stack, make a play attempt, like so, and then I usually say no to the discard attempt to use the wild card, rather. I usually say no to using the wild card. Alright, so we have some attempted melds. Yeah, they're not going to work. And we'll just say yes. We'll add to the 7 this time. And it's not going to work because the score is not going to be enough, and it shouldn't work because 7s are only worth 5 points apiece, and the 2's worth 20, so that's... See this? It shows negative 165. That's wrong. It's actually 10 plus 20, which is 30, so it's wrong. But, as you can see, the game actually works. And we're going to discard another 6. And, bam, now it's the other player's turn. And, like I said, this is online. This is an online game right now. It's pretty cool. So, let's go ahead and kill the script. We have verified that everything does indeed work. And all that printout is our logs. We need all that. I actually modified it to where all the logs are printed out after the fact so as not to influence the performance of the game. So we have two options. I basically have a switch, and if I turn the switch on one way, then it will print out the logs live during the gameplay, and then if I have the switch set to the other option, it will print out all the logs upon termination of the script after we make a playthrough so that we can review the logs without them influencing the performance because that will cause bugs. Actually, printing out to console takes a lot of it costs a lot as far as performance wise. Okay, so we did a little game test, so we'll just put that we did that and to know that everything went well. This is so loud, even though the volume set at the 50. A little better. There we go. Alright, so let's just put that. Did a quick gameplay test. Everything seems to be working correctly, other than like the score bug, but we already know about that. That's no big deal. So what we're gonna do now is we're gonna pick up where we left off day before yesterday, which was, let's read our devlog and see. So we continue working on deciding which features needed to be added to the project. We determined we don't need the menu screen implemented before the reconnect system, and we created the first pass simple solution to reconnect system. Client side. See client py end of file notes. Stopped at line 647 in client. So let's go over there and let's jump to 647. Alright, so we got our notes here. And now we can get rid of this little line. Ready game test, blah blah blah. Alright, cool. So we're gonna pick up there and in things to do, let's make sure that we have this current issue reconnect system, other client, disconnect CS object. Yeah, so we'll leave both of these. They're interconnected. They're basically two parts of the same problem. But we're going to focus on the broader implementation of the reconnect system before we address the more specific other client disconnect client-side logic, which is basically just verifying that we let the other client know that the other client has disconnected from the game, so they're not just like sitting there thinking that, so the player is informed that their comrade / opponent is out of the mix temporarily. Alright, so we're going to look at lines 639, 647 in client, and we're going to continue the brainstorm first pass. So this will be our second pass for our solution here, for basically the overall grand scheme of things, how we're going to make this all work out. Alright, so we're gonna stream. I forgot to do that. Music just for a second to see how the volume is. Looking handsome. Look at that handsome man right there. Disconnect. A little old though. Can see it in my eyes. So the player is informed. Yeah, it sounds good. Looks good. Everything's cool. Gravy. Beautiful. Alright. See you later, YouTube. Back to the stream. Okay, so let's read our brainstorm. We have a suggestion of using a while true, and basically within it we have two parts. We have the menu screen function call, and then if reconnect, determine which part of the while loop to re-enter. Okay. And I have suggested to myself that it would be possible perhaps to use, well, I had done an assessment of a while loop as far as re-entering it, like just from the very beginning, instead of trying to re-enter it into a certain part of it. But I'm not sure if that analysis was like completely conclusive, you know, that I was right in my assessment. But I remember at least like half-heartedly feeling like I could just jump back in at the beginning of it and that everything would be fine. So I guess we could just try and do it that way, and then if that doesn't work, because it's less work, you know, it's easier, it's less work, I don't have to worry about adding in more code, I can just leave it as it is. When we reconnect, we will just jump back into the main while loop, like just raw. We're not gonna worry about. So for instance, when we reconnect, it will just literally start from this line right here and connect, and just straight up as this is, run it. Now we can add in a couple spots like this preliminary section, which assigns the client ID. We might not need to do that. Well, actually we would, wouldn't we? Yeah, we actually would need to do that. Well, unless we loaded it from the save file. So like, and this is where it gets complicated. Um, so there's two different forms of disconnects. There's the disconnect whenever we get disconnected from through the network. In that case, the client script actually doesn't crash. The client script stays alive, and in that case, it's very easy for us to back up where we left off, because we have to worry about loading the state of the game from an save file, because the client script file is still running and it retained all that information. So it's just a matter of basically reconnecting like to that game against that particular client that was matched up against, and picking up where the game left off. You know what I'm saying? Like have a smooth re-entry. We don't have to worry about applying external save data. In that case, we do have to worry about like, for instance, in that case where the client script doesn't crash, we actually wouldn't have to worry about the client ID assignment. That would already be assigned. All this stuff would already be assigned already. The current client, all this stuff. All of this code would have been run already, presuming that it disconnected after, you know, the assignment of this data. Technically, it could have disconnected in the middle of this, you know. It is possible, and obviously we will have to account for that in our reconnect system, to where when it is only even when the client script stays alive, we still basically have to, like, we basically need to have a checklist, right? To where should I write this down? I need to write this down, but where should I write that? I'll write this down in the reconnect system. Okay, right here. So we'll put brainstorm notes. All right, and just start a new little thread here. So we have two main let's just say two types of disconnect, right? And one of them is going to be network issue DC. In this case, the client I script is never terminated. Therefore, we don't have to load in data from a save file. We still have to determine proper which data may have been lost, or which data, we'll put this in two different things. So we still have to determine which data may have been lost, and then we still have to determine which data may not have been applied yet. You know what I mean? Applied / assigned yet. So to this point, to these 2 points, we should probably have we'll call it a checklist function. I feel like that would work, right? Where checks to see if data has been applied, assigned, if various data. Now, honestly though, that seems extra. Like, couldn't we just rerun this? Instead of checking to see if all this is already assigned, couldn't we just redo it? Wouldn't that be just easier? Like, the performance difference would be negligent. Like, honestly, this might be a more performant than doing a check. And see, this is the most difficult part. This is the hard part. This is the part that I've struggled with when my brainstorming. Like, I've thought about this a lot. That's kind of getting ahead of myself though. I don't want to get ahead of myself because usually when you get ahead of yourself, you can overcomplicate things, and I think that's probably what I'm doing. That's why it gives me anxiety, so I should just cross that bridge when I get to it. Too far away from it to really see it clearly, probably. So, we still have to determine which data may have not been applied assigned yet. To these 2 points, we should probably have a checklist function, check to see if various data. Honestly, though, wouldn't it be easier just as performance to simply rerun the code assignment again? And we'll call these hard reconnects. So we're going to have a terminology for them. We'll call 2 types of disconnect. We'll call this the soft disconnect. We'll call it the soft DC. It's a network issue disconnect. And then we have the hard DC. And that is like an actual computer PC crash. We'll call it OS crash. OS/PC crash. In this case, the MyPy script is terminated abruptly. We would need to rely on external save file to restore data in this case. We'll just put must use external save file to restore data. We'll actually remove that terminate abruptly. Yeah, we don't want to put like 2 points on one. Put like bullets, 1 point. Must use external save file to restore data. And ultimately, this means that um, implies data must be constantly updated, saved. Saved is the proper term, not updated. Because data must be constantly saved to external save file. And to this point, could use async await for improving performance during the IO operations, as this is what the library serves best. That being IO operations. Yeah. Implies it must be constantly saved to external save file. Could use async await. And now, okay. And this is another question. One thing I thought about was using another thread, a save thread, because honestly, like, that would be the way to do it, because otherwise we would have the client file, right? So we have our client file, and in our client file we have all of our code that runs so we have our client file with all of its various lines, and if we wanted to add in the save operations into this, it would be like every time to save the stuff that we just changed, and ultimately that will cause a lot of bloat, it will make it a lot harder to debug this code, the black original, like we'll call it the game loop code, and you know, there's a lot of just trouble associated with that. But if we did a different thing, namely we had and we could put it in a different file. We could put it in a different file. We could put it in the same file and do a different thread. I'm not so sure about this. So this would be our client file, right? And we could have the game loop code right here, and then we would have the save file code here, which ultimately would detect anytime we changed anything here in black to be saved to our external save file here. And then ultimately it's going to write all of this data to the save file, and then when we connect, it's going to, when we rerun this script for the second time, it's going to grab from the save file to restore the data, the state of the game. So we'll just put S for save, and then C for client. Alright, and then what else? Okay, so from there we have, like, what would be the better option here? In this option right here, we are using a new thread, but it's in the same file. So this would be, why is it not blue? I clicked blue. Like, here we go. So this is thread 1, and then this is going to be thread 2, right? Or we could have two separate files. We could have the C file, and then we would import the, we would just import the pink file, the save file, into that one, and then we would have our save file with its code, and then this would be thread 1, and like T1 would be started through this blue line, so it would be started here. And then when we imported the save file, we could then, you know, immediately after run the save file function, which would create the new, call it the save thread, and in that way we would have the two files separated from one another. Now, this save script would be a Python script, because this is not going to be a pickle file. We need the third external, we'll make it orange, would be our pickle file. So then we have our s.pkl, that's what you call it, pickle, that's what I call it. And this is actually going to have, you know, just the saved data to it. I think pkl is the correct file format. I'm gonna have to look that up. So I'm opting to, I'm tending to think that this option, on the right side, is better. So we're gonna put an X over that, and we're gonna put a green check over this, because this is good and the other side is bad. Right? So, and this would be T2 here. Like, I know that doesn't really make sense, but I understand it. It makes sense to me. It's my own chicken scratch, so I understand what it means. Now, obviously, I'm trying not to yawn. Damn it. So I don't want to be tired. I'm not tired. I'm not tired. I'm good. I'm not tired, guys. Just need more coffee. That's all. Drink that coffee, cuz. Drink that coffee, cuz. All right. So, before we go any further, though, let me just zoom out, because this is the most important thing, right? Is making sure we're taking a step in the right direction and not taking a step in the wrong direction. Meaning that we're just gonna have to erase all of our progress because it was a bad decision, incorrectly formulated. So, do I actually need this? That's the number one. Do you need it? This is always number one, necessity. And we went over this last. I got excited and then immediately depressed right after. I got excited because I was like, hey, if we have a soft disconnect and all that happens is the network crashes, the client script is still going to be running on the client's computer. Therefore, all the data is still going to be saved locally. We don't have to load anything in from an external save file. Therefore, we don't need an external save file. And then I got depressed again when I remembered Oh yeah, there's another type of disconnect. A hard disconnect is just what I would call it. It's just a word to describe it, wherein the actual computer crashes, turns off, and in that case, the client script gets terminated. So yeah, a hard disconnect, you lose your local client data. It's terminated, and you have to, in that case, either get it sent to you over from the server, which is just like having a save file in the cloud versus a local save file. And the local save file obviously makes more sense. It's more performant, it's smarter, easier, better, just yeah. Anyway, so I think like there isn't a way around it. If you're gonna have a system that accounts for hard disconnects and reconnects, you're going to have some way to restore the data to its previous state. And the way that I can think of doing that would be, well, you could use a database actually. Um, and I did want to use a database, like I did want a database. Necessarily, I don't want to use the wrong tool for the job though, you know what I mean? Like, also want to learn more file operation stuff, which would involve file operations, obviously, because I don't really use that in the project currently. I don't really have a lot of experience with file operations. So I could use a database for this, but I think I would prefer to use the right tool, which I would say the most fitting tool would just be a basic save file, like AL or whatever. So yeah, I think the necessity question, is it necessary? Yes, it's necessary for us to have an external save file. So with that out of the way, the next question is this proposition here with our client, like, what is the mechanism or the methodology we're going to use to make these saves and to restore the game's state to whatever it was prior to the disconnect. Well, and there's different facets of like that solution, right? There's like the part of like I'm thinking more specific code, like, but first, you zoom out and then you zoom in. You don't start zoomed in and zoom out. It doesn't work like that. So let's stay zoomed out, and from a zoomed out perspective, from a higher level perspective, this little chicken scratch I made is the proposition for the proposition as the solution for the problem, which is to have our client file, which would be client file over here, and this is going to basically contain all the code that runs the game on the client side. All of the game data is stored here, or progresses here rather, and yeah, this is like where the loop of the game, where you redraw the screen, you make a decision, you redraw the screen, you make a decision, you update the data, you transfer the data. All that is handled on this client file. And then we have our save file, which is a we could put this inside of the client file, as in where we put the red X. But I think it's just better programming practice to have these in two separate files. It's just like having two separate functions for, they like for you to keep a function to one specific purpose, in the same way, you want one file to have one specific purpose, you want one class to have one specific purpose. It's just, it's simple, basic reasoning skills here. You want things to, you want to have your components divided with a easily visible distinctions, So we would probably do well to do it this way and put the save logic, we'll call it the save logic file, or the save thread file, something like that, and it is going to contain all the code that is going to basically be run in parallel. So we're running in parallel, so just like draw two parallel lines right here. So these two files are going to be running in parallel with each other concurrently, using multi-thread. So I should use blue, so that's the color to designate multi-thread. So we have, these two files working concurrently. We can import the save logic thread py file into the client py file and initiate the second thread through we can initiate that code through, like, we would have it in a larger function. We'll just use this gray to designate that function, and then once we get into this file, we would just execute this gray function, which would cause all of this code to run, which is basically going to be on a loop. Like, it's going to be on a while loop. It's going to be running constantly. Just basically looking for changes that are made to all of the different data points, and as those changes are made, they will be saved. Now we're gonna have to obviously get into the specifics of that. I just want to make sure, first of all, that the outer framework, the methodology for accomplishing the task is reasonable, that this is not a dumb decision that I'm going to go back on because I realized it was stupid in the future. So let me just think about this for a second. Yeah. So save file, client file, import the save file logic. So we go over here to main. I'm pretty sure we're gonna go ahead and roll with this. I feel like this is a wise decision. This is a good way to accomplish to solve this problem. I think it's probably the most, like, I think this is a pro decision. This is a good decision, right? This is how a professional programmer would handle this. Maybe. At least a professional junior, let's say. Yeah. Well, and then we have our S pickle. So we go from here to, I'm gonna do all this. We go from here to here, and then we go from here to here. So this file, call it spy. Spy is going to actually be the one that is writing all of the data to the spickle. The spickle, which is the actual save file. And then whenever we reconnect, we will import all the data from the spickle. upon reconnect, write in all that code, reconnected, and obviously the logic that handles the reconnect is going to be inside of this file. Okay. And right, yeah, I think that's a good idea. I think we're going to roll with it. Okay, and go with that. Wherever the wind blows, bro. You know, that's kind of how coding is. Where the wind takes you, you just go. Don't fight it. Just go with the flow. Just make sure you keep bookmarks every time the wind shifts. You know what I mean? Bookmark, 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 so that you know where you know, you're leaving your breadcrumbs. Your breadcrumbs are very important. Make sure you leave your breadcrumbs. Okay, so we have two types of disconnects: soft DC, hard DC, and let's I'm gonna put, what are you gonna call this? Call this file logic structure. File slash logic structure. We'll say overall file logic structure. Okay, and we have FinePy, which contains gameplay, logic, progression, reconnect, connect logic, as it is currently. We're not like gonna modify this file. Then we have our, we'll call it we'll just put essay right now. Essay pie, which, butchered that, didn't I? Which contains the save thread logic for saving the data to the sf.pickle, which is called sf for save file, sf.pickle. And then we're gonna say imports sa.py, and then starts new thread. We'll call it save thread logic thread. Start save logic thread via function call, maybe some of that. And which needs to save thread logic for saving data. And then we have the sf pickle actual save file pkl format, actual save file which contains the saved data. Then also has logic which grabs from sf pkl in case of DC. And we will distinguish between the overall file structure and the overall logic structure, right? Is that good? Is it good? Is it safe? I don't know. We'll find out. Okay. So the overall logic structure is that So like this is how everything runs. Like this is like describing how your engine works. So we have client, and this is obviously all client side. This is all client side operation. Um, really need to put that whatever. So we have client side operation. Client pi is initially, and then say pi good save logic thread via function call have at this point have two client side threads, and then SA by handles logic saving data to SFPKL. SFPKL saved to hard drive, whatever, and DC and subsequent reconnect. Client pi is rerun. Pi has logic to detect if reconnect versus initial connect. And then, you know, I hate when people say right as they're talking, as if they know. They're self-validating, and then I do it because I hear people do it so much. It makes me mad that I do it. So I'm listening to myself as I say it, and I'm like, don't say that. You don't know if that's right. It makes me wrong. Porn DC and subsequent reconnect. Client pi has logic to detect if reconnect versus initial connect. And, if reconnect, then what? If reconnect, we will I would say we would probably have the also contains function for logic to function for logic, function with logic to restore data state from, let's say, to client pi, right? So, nope, maybe not, right? So if reconnect, call SA by, call it the reconnect restore data function. To restore data. Well, actually, if reconnect, there's I'm assuming hard disconnect, but this is supposed to be an overall logic structure, which would also account for a soft disconnect. So in that case, we should say what do you see in such reconnect? Client pi is rerun. Okay, yeah, that's correct. Regardless, client pi is going to be rerun as object if reconnect versus initial connect. And then we have to say if reconnect. We have to be a little bit more specific here. We'll have to say if hard DC, and we'll just write this out like straight up Python. If reconnect, if soft DC. And if, so basically, now we're at the point of writing pseudocode. We went from visual brainstorm to word form brainstorm to pseudocode, and then that turns into actual code, and that's pretty much the process that I use for developing a new feature. It starts here, then you make like a diagram of it and think about it real hard, and then if that passes the logic test, then you move to the next step, which is writing it out like this, brainstorming, and then you kind of like sort that and transform the brainstorm into pseudocode, and then you turn that pseudocode into real code. What is reconnect, client pi rerun, client pi logic detect reconnect versus initial. If reconnect, if it's a soft DC, well, in that case, what do we do? If it's a soft DC, well, in this case, we're not going to access the external file, so we don't need to worry about the save pi or sfpkl. We just need to worry about client pi logic. So then we would and I don't really know exactly how to accomplish this, honestly, but I know what needs to happen is we need to re-establish proper, we'll call it clean re-entry into main while loop, and also re-establish clean re-entry into re-entry of data assignments. So like making sure we reconnect, we haven't lost any assignment, you know, like we're not, it's not using errant assignments and stuff because whatever reasons that could happen. Okay. And this would probably I kind of will like I want to cross this bridge when I want to get a little closer to this before I determine exactly how we're gonna do this with re-entering into the main while loop. Like there is obviously we could use like a progression integer type system that is, it basically acts as like a checkpoint, determines what point of the loop we're at. So like this is the main while loop I'm talking about here. So all this we have, you know, we have our filter section, we have our receive section, we have our send section, and you want to re-enter the process, you know, ideally exactly where you left off. But that is what I have struggled with, figuring out how to re-enter this section, re-entering into the proper section, and even the section within a section. You know, you want to Like if we DC at line 431 and I come back and we start back at 426, you know, like that's gonna mess things up, because if there's nothing in the ready when it gets to this line, it's not going to enter back in. You see what I'm saying? It's not gonna enter back into this, and it's not going to continue. You know, it's not going to just start up here, which is what you need it to do, and you can't have it jump back in at line 437, because then this data hasn't been properly applied. See, because this turns into a logistical nightmare, because this issue applies to the entire while loop. So how do you determine where to re-enter? And you can't just say, okay, we'll just scrap the data you already had, because obviously it's not that simple. You know, like the data that you had is probably the next data point that you needed. Like, none of the data that gets transferred is junk data. We already weeded out all the junk data. Everything that gets transferred and received is necessary. Like, you cannot continue without it in the game. So this is actually very important. And I would like to think that there's a really simple solution to this. Maybe like another thread that basically, you know, like we could have, what about this? What if we had another thread that ran concurrently, and upon DC triggered an event that would cause the main thread to basically pause its, you know what I'm saying, to stop in its tracks. But how do you get one thread to tell another thread what to do? That is usually handled by, like, well, I don't know if this is true. I know you can do that in multiprocessing. You can use pipes to communicate between processes and have some sort of functionality like this, but I'm not using multiprocessing. I opted to use multi-threading. I did an assessment on which one I should use, and it was determined by truly using multi-threading. Multi-threading was better for this project than multi-processing. So, because we share a lot of data, and when it involves shared data, you want to use multi-threading. I was thinking really server side when I made that decision, because client side was and currently still is, until we implement this new save thread, is a single threaded operation. So we actually could use multiprocessing on the client side if we wanted to, instead of multi-threading. Now, I don't know which one would be more. Well, I think obviously multi-threading would be more proper, at least for the save system, because multi-threading works well when you're using shared objects. Like, we're literally sharing every object in the save system, so that is actually the point of the save system, is to share every object that is in the client file and transfer it to a save file. And multi-threading has memory access to all the data, and the client file makes it ideal for application, as to where multiprocessing would not be optimal for that process, because multiprocessing does not use the same memory space. Therefore, it would not know what any of the data in the client file is. It would have to be piped to it, which we don't want to do because that would just be dumb, right? Use multi-threading to instantly have access to it without having any additional operations on top of it. Now, with that said, as far as the not the save file system, but what was I talking about? I just had like a brain fart, and what was it? We were talking about. Oh, right, the save system, right? Or rather, not the save system, the re-entry, the re-entry into the main while loop from a disconnect, from a soft disconnect, hard disconnect. Well, this would apply to both of them, right? This would apply to hard and soft disconnects. In both of those scenarios, you need to determine where you're re-entering into the main while loop. So okay, so yeah, and then the proposition, yeah, the train of thought I was going down was if we used another thread that basically whenever we disconnected, there would be basically like a tracker thread that all it did was keep track of where, like the line number. You know, like literally we could keep track of the actual line number. Maybe. You know what I'm saying? Like, we could keep track of the line number, and I don't know if that's actually possible though. Well, as opposed to the line number, we would be able to keep track of the send, like the data itself, so that whenever the data is updated, see, and this is where it gets complicated, like because whenever, let's say we crash right here at 4:30, crash at 4:33, how do we pick back up at 4:34? Because scripting doesn't work like that, right? It doesn't. It's not just gonna back up where it left off. I have to tell it to do that somehow. And that's pretty complicated because we have to make sure that the send ID actually got updated. You know what I mean? But I don't want to overcomplicate something that could be solved simply because I have done that in the past and it turned into an absolute nightmare where I had to refactor code like multiple times over to a more simple state because I just didn't spend enough time thinking about it and reasoning through it properly the first time, unfortunately. And it cost me like a lot of time and a lot of pain, and that could have been avoided if I would have just spent a little bit more time thinking it through. So we hit our 68-minute mark. I'm gonna go take a break because that's how I do it, and back I'll hit my timer again, and we're gonna do another 68 minutes. So I will go ahead, take a little break real quick, and I'll be back in 5 to 10 minutes. Okay, I'm back, I'm back. Oh man. Oh man. I'm back. There's a little bit of a break right there. Sorry, that was probably more like that was a little over my intended 5-minute break. That was more like a 15-minute break. But you know, it is what it is, right? Why am I breaking up gum? I already got broke up gum. A doofus. Doofus. Okay, baby. Okay, baby. Okay, baby. Let's jump back in. Okay. We're doing the jumping, the back, the in. Let's get away from Michael Scott. Michael Scott. What's his name? Michael Scott. Scott Michael. Whatever the fuck his name is. That guy. You know. The man, the myth, the legend. Okay, so we made our brainstorm. We're writing it down, right? And now we're now at the pseudocode stage. Okay. So if reconnect, so upon DC and subsequent reconnect, client is rerun. Client has logic to detect if reconnect versus initial connect. If reconnect, we check to see if it was a soft DC or a hard DC. In the case of soft DC, we reestablish clean reentry into main while loop, reestablish clean reentry of data assignments. Don't know how that's going to be accomplished yet. Just think about this. Okay, yeah, and that's where you're gonna. Right. So that's where we were. We were trying to reconnect. Both of them. And we'll say for both hard and soft DC. Determine how to re-enter into main while loop at proper location. Okay. and like I'm trying to think simple here because I know that there's like some, which we might have to be more complicated than more simple, but I'm thinking of a sort of complicated system where basically we have a separate thread or something that basically just keeps track of the things that are being updated. So like let's say we're at line 431 and we're updating the current client dot received data structure, right? We're updating this. So in that thread's eyes, this is the last thing to have been updated. Well, then we would like have like basically a dictionary or something has the places where this data structure is updated at. It's like it might be updated in 3 different places in this file or in this main while loop, right? And then we would need to determine at what point, which one of those 3. And that seems dumb. Like, wouldn't it would be better to keep track of the line number, right? You just literally keep track of the line number. I feel like the line number is key here, but I have no idea how to do that. Like, other than every other line having like a record, like a recording of, hey, we're at this line now. Hey, now we're at this line. Hey, now we're at this. Like, there's got to be a better way, right? And hard coding, like, new line, new line. Just, that is so redundant. There's gotta be a better way to do that, to keep track of where we are. Now, we could say that the save file itself is basically gonna do just that, right? Like, the save file is going to be updated every time we update this. It's going to reassign the new current client.receive data namespace rather to the new data. It's going to save that. So that in and of itself is not, it's not a line by line tracker. You know what I mean? But it is a object to object tracker. But that doesn't work. Like, we couldn't use the object to object tracker as a line to line tracker. We couldn't. That's one thing that you learn in programming. Being able to give something multiple purposes instead of, creating a line to line tracker when we could use the object to object tracker with slightly different modification to be a line to line tracker. It saves, you're basically reusing old code. Anyway, I don't think we do that because that doesn't take into account these if statements. It doesn't take into account this. Like, and then on top of that, right? Let's say you could keep track of it. How do you re-enter at line 437? Like, how do you do that? How do you re-enter at line 437? If you left off at 434, how does that happen? So ultimately, it seems to me like the main requirement for this could be, maybe, probably is, that to have some mechanism that literally like pauses. But that's not possible, right? Because for a hard disconnect, there's no way to there's no way to do that, right? If there's a hard disconnect, there's no way we would have to have basically saved this data somehow and then restored the data. So I'm kind of seeing like two different worlds here as far as solutions to this problem. One of them is basically some sort of line tracker system that keeps track of exactly where we disconnected at, and you know that doesn't give us the solution for how do we re-enter into that section at that particular line. Like if we did a line tracker system, and let me write this down, so because this is really important. So we're gonna say determine how to re-enter into mainnet. We'll call this main while loop re-entry system. All right, and we have option number one. So say option number one is, we'll call it the line tracker plus, what do we call this, like partition, what do they call that word, compartmentalized? That's one way, that compartmentalized sections. But that just doesn't work, right? Like that's compartmentalized while loop sections. So I was thinking we'd have a line tracker thread that keeps track of exact line point of DC, and then also have compartmentalize while loop sections associated with particular ID, wherein we save that ID as we enter into that section, and re-enter based on a checker for each compartment ID. You get what I'm saying? So like we would have let's say this little code section right here is assigned to compartment 1, and then we would have an if block right here that would say if compartment ID is equal to 1, then we would go to this section of code. But as you can see, like the way that this is structured, it's way more complicated. It would first have to check if ready, and like, you know, how do you accomplish that? You know what I'm saying? Like, you have to I'm not sure that we could do it this way. I don't think we could do it that way. because let's just say we went with this like overall system, and we put this little, all these different compartments, we'll call them, all these different little sections of code, like little tiny snippets of code, we put them in functions, right? Put them all inside smaller little functions, and then when we reconnected, we would use that compartment ID to determine which little function to call. So like, you know, we would be using functional programming associated with basically like progression or compartment ID, and you know, then we would run each particular section of code, and that actually, I mean, that could work, right? The only thing is that would require a pretty massive refactoring of this file. Granted, this file is not extraordinarily complicated. Like when you count out the comments, the initial little section right here, and like the first 100 lines, which is the class definition, and then the dir check. So really, the first 320 lines are discounted. So we're looking at from 320 to, you know, let's just say minus 50 lines of comments. So we're going to go from 320 to, yeah, basically from 320 all the way to 637. So you're not looking at a terribly huge amount. You're looking at basically 300 lines. We'd be looking at a 300 line refactor. And we would basically be compartmentalizing all these different sections of code into little functions that are associated with IDs. And that would actually like work, right? Because when we reconnect, we would just grab that saved compartmentalized ID, compartment ID, whatever you want, progression ID, and that we have like a dictionary that associates each ID with a particular function. So we would run that particular function and then go forward from that point. You know, we would have like a loop dictionary that, you know, connect all the little functions together and ran them in the proper order, like boom, 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 you know, function 1, function 2, function 3, function 4, function 5, associated with 1, 2, 3, 4, 5 in the dictionary, and it would basically just increment through those. So if we picked up off at 3, we would start at 3, and then it would go 4 to 5, back to 1 to 2 to 3 to 4 to 5, back to, you know what I'm saying? But the thing is, that would still require us to intelligently re-enter, you know what I mean? Like, these sections would have to be obviously intelligently structured to where like, let's say we would still have the issue of picking up in the reapplying, or whatever you want to call it, picking up in the right place within a compartment. So let's just say this is a compartment, this little snippet right here, you know, and let's say we crashed right here. Okay? If we crash right here, well, we have this data saved, but we don't have this data saved. So how do we know, you know what I'm saying? How do you know that you are picking up at the right spot? Like if you rerun this part, you know, like would you Well, for this specific snippet of code that I just looked at, like this is safe. You would be like if you crashed right here and then you reconnected and then restarted right here and reapplied this, none of this would cause you any issue. But I'm pretty sure, at least I can imagine, and this is more so with like the data transfer sections, like let's say what else would be like another compartment. We'll say like this would be a compartment. Let's just say these 4 lines would be considered a compartment, right? If this is a compartment associated with, just say, progression ID 4. So this progression ID 4 function, we would start here, but let's say we crashed right. Okay. So this data has already been applied and saved, but this data hasn't. Okay. You would be rerunning this because this is the beginning of the compartment, and that would errantly re-receive well, you wouldn't re-receive, you would receive new data because you already received the data, but you don't know that, right? In this scenario, we don't know that because we didn't have the logic to say don't start there, start here at this time. And that would be problematic, right? That would not be correct because this would be bad code. You would receive the next data set, you would receive the next sender ID, then you would, the data that you had previously received would just be like thrown away. So as I was saying, there's basically like 2 worlds, right? And this compartmentalized system, let's put basically divide main while loop code into very small sections with associated IDs as functions. Would use progression ID to choose which compartment, we'll just call it function, which function to call upon reconnect. Problems is basically seeking to do a line by line search, grab track would be smarter to keep track of actual DC line instead. And then we'll say is also would also have same weakness within compartments, how to know which line to start at. Or which data to not assign, etc. Technically, we could avoid this problem by keeping timestamp of data point change save thread for each data structure and checking each assignment for each assignment, see if it has already been based on time of disconnect versus time of last data change, if that makes sense. Comparing TLDR, compare timestamp of DC versus timestamp of last data change. Timestamp of last data change. For each data point within compartment function. And now this is a viable system here. This little proposition, like this is technically a way to do it. It is clean. It's very clean. That is a very clean way. Like that it would be pretty performant. It would be clean. It would be tidy. It would require downside requires a very thorough refactor of basically entire client pi file. And obviously we want to avoid entire refactor because, you know, that's a lot of work, right? So there might be a better way to accomplish this. And so another, like, or I was saying, I see two worlds here. In one of the worlds, we keep track. This is option 1, line tracker. We'll actually have two worlds. We'll say world number 1. In world number 1, we use some mechanism to keep track of DC point, line number, line no, etc. And re-enter. And then this option is within this world, okay? But then we have world number 2. World number 2 is we don't worry about keeping track. We don't worry about keeping meticulous track of progress, etc. Instead I would call this like we would call this a reconnect protocol. Whatever, you know, something like we use a reconnect protocol, which would be basically a list of tasks to be performed in such a way that picks up where we left off, and this is, I'm trying to search for the words here, picks up where we left off data wise, but not logic line wise. That makes sense. So there's a better word like to describe what I'm talking about, but basically when we would reconnect, like we don't worry about what line, whatever. It's just like forget that. That's too difficult. That's like impossible. Don't worry about that. Instead, we'll have a system that is rigid. It is not dynamic. It doesn't have anything to do with where we fell off, whatever. Regardless of where we fell off, we get back on the train and we have a specific set of tasks ordered and structured in such a way that like applies the data that we had received but didn't apply yet. Receives data that is ready to be received but hasn't been received yet. See what I'm saying here? It's a completely different philosophy than like meticulously keeping track. It's more of a just a safety net restart protocol. Like, okay, have to figure out. It's kind of like if you have a driver that's delivering packages, right? Okay, so you have a driver, he's delivering packages. He's using his software. He's using his phone. We'll just call it his phone to make these deliveries in a certain order. He's got like it in his mind what he's gonna be doing next. He's got his day figured out. But then all of a sudden he gets sick. He has to leave, right? And then you have a new driver that comes along, and he has to finish running the stop and all the stops and running the dude's route, but he doesn't have the stuff in his head that was in the other guy's head. He's got to figure out his own way, but at the end of the day, all those packages need to be delivered, all the pickups need to be made within the proper time frames. You see what I'm saying? So like, instead of having a perfect tab on exactly what that driver's thoughts were, instead you just have like this checklist of like, okay, well, what was the next stop on his board? You know, et cetera, et cetera. Like, what time does this pickups need to be made? I feel like I like the idea of World 1, where we keep perfect track of everything. But honestly, I'm just not sure that it's possible, one. And number two, I'm not sure that it is a better option than World number 2, where we just use a reconnect protocol, and that's some work, you know, like obviously both of them would require significant work. Not gonna get past this section without doing work. It's gonna have to happen. So I don't know. See, right now I'm 50-50. Like, World number 2 is not gonna be easy either, right? Like, we would have to basically recreate this file. We wouldn't refactor it. We would create a new set of code, completely separate, but structured such that it will get us back on track that we were, you know, to where everything is perfect. It has to come back perfect. It can't be off a little bit. It's gotta make sure that if we had received data, but that data hasn't been assigned to the sender ID, to do that. I'm thinking also with this system, it would use timestamp as well, and it would probably also have to refer to that save thread which would basically keep track of when data was last saved. So basically, like, you're keeping track of, let's say, it's similar to World 1, it's the timestamp scenario, but instead of using the compartmentalized function of smaller, code snippets to pick up where we left off, we would just have this long list of like things to check and do based on those checks when we reconnected, which would entail checking to see if current client.receive data was assigned like right before the disconnect, and if it was, then that means we might not have properly assigned the sender ID, so then we would need to assign the sender ID, etc., etc. Yeah, this is not easy, guys. This is gonna require work. I really don't think this project. This is pretty much like the last feature. I'm not adding any more features. There's gonna be this feature, which is, it's all interconnected. The perfect save system, the reconnect, the perfect save and the reconnect are two arms to the body. Like they can't go without each other. They two sides to the brain. You like, it's not, can't have one without the other. So fuck. Yeah, this is gonna be hard, man. This is not gonna be easy either way. So we don't worry about cumulative check. Loop. Instead, we use reconnect protocol to do this in such a way that picks up. Say similar to World 1, we would use timestamps and line numbers to determine which data points to pick up at, to reassign, etc. But differently from World 1, it would use an entirely separate set of code, the protocol. And that's what we call the reconnect protocol. Prior to a standard entry into the main while loop from the beginning. Yeah, so we would re-enter into the main while loop from the very beginning of it. And I'm seeing that, like, put a keep, right? So point. Why is this? Folks are ugly. How ugly they've gotten. It's just how it works. It starts small, it gets really ugly, then you have to make it pretty again, and then you just keep transforming it until it's a final file structure, overall logic structure, CS operation. If reconnect, okay, and then we have main while loop your entry system. Now this is gonna be moved. Can't all exist right here. We gotta. Okay. So now put. So well logic. Finish this section. So that needs to be finished, but we also are going to right here at this same level, indentation level, the main while loop, and it always messes up the indentations. That's one thing I don't really like about VS Code. I don't know why it always goes to the right. See what I'm saying? Why doesn't it stay the left whenever I do Shift Tab? Why does it move back to the right? It should have a priority system that allows it to stay where I told it to stay. To check that first. Anyway. Okay, so we have the main while loop reentry system. We have world 1, world 2, and option 1 is the line traction. And then number 2 is don't worry about community concern progress from the while loop. We use reconnect protocol, which would be list of tasks. Symbol 1 we use timestamp 33 would be an entirely separate set of code. And I'll put key point here. So we're going to put key point that must be remembered is seems as if line number tracking for exact disconnect is essential. Rather that you need to figure out where exactly DC'd at. This could be accomplished via timestamping, tracking, or like, yeah, well, timestamping last time data points were changed. But that's far-fetched. Or seems far-fetched. And this is just how it is at first. You just write everything and then you trim off the fat. This could be a combination of timestamping or what was the other one? Line number tracking. Seems more reasonable. Like it seems more reasonable that we could do that. Because if we did timestamp, like well, that's correlating a timestamp with a line. But what we really want is the line. Right? That's what we really want. We want that line number. We need to know where exactly we DC'd at. And it's just like, you know, when you get a traceback, it can tell you where the, even though it gets caught through an accept clause, it will still tell you like exactly where you, similar, and we'll just put for line number tracking. Similar to how tracebacks are initialized via accept clauses, but still able to tell exact line of error prior to, you know, separate accept clause location. Need some functionality similar to this. That's how I feel, bro. So let's ask Chippity, Chippity, Claude, the God, aka the great IA. Let's ask them. Pooted Potter. What? Potter pooted. Man, where are we at today in 2024? Okay, where are we at, bro? Anyway, all right. So Python. How can I determine what line we were on? We were at when my client disconnected from the server, from the client's perspective, so that when we reconnect to the game server, we know exactly where to pick up at in our main while loop. I think that's a good way to ask this. Temporarily default concise responses. Yeah, I like the concise responses anyway. Ooh, damn, it wrote the code up for me. Ooh, see what I'm talking about? Claude is something, bro. Claude just cooked up a little book for me to read that quick. Let's look at this without, like, how do we see it but more fully, dude? I want to see it in this little small ass section. Okay. So it's saying import JSON, so it's gonna use JSON. It's gonna use OS connection state tracker state file connection state JSON self state file equals state file current line equals 0 load state save state load state. I don't know what load state is. What is load state? State tracker, so it just calls it. Okay, so load state is this function. Load previously saved state if it exists. Save state, save current line number and any other relevant state. So state equals line is self.current line. Add other state variables as needed. With open self state file, W as F, JSON dump. Okay, right. Then we have load state. If OS path exists of self state file, try with open self state file R as F. State equals JSON load F. Self current line equals state at line. Except JSON error key error file not found. Okay. Equals 0. Update line. Current line equals line. But how do you get the line number of? How do you do that? Main client loop tracker equals connection state tracker. Server connect to server. Number equals tracker dot current line. Resume from last known position. While true, try. Server seed process state update line number after successfully processing. Plus 1. Tracker update line number. Yeah, but see that's what I'm saying though. You'd have to put this line number increment after every single line. You know what I mean? Like there's gotta be a way to do that, right? Finally. Connection track. Turn phone call. Okay, so I understand like what it's getting at here. but that is silly. That is silly, right? Let me read this. I should have read the English version first. Help you create a way to track and resume from the last known position in your client code. Season parts if you keep persistent state tracking, automatic state saving on a disconnection or crashes. Easy resume from the last known position. Okay. Direct usage in your main loop. I mean, I like the overall like idea. Like this is good as far as the overall idea, but realistically, this is not work. Specifically, okay, let's say, can we? Let me see. I have a problem with your solution. It requires manually updating the line number every single line of code that is run. I need to have something like another thread or process, preferably a thread that keeps that automatically or dynamically detects the line number as the other main client thread is running perhaps using .line no or some similar concept. Let's see what Woody would call. Okay. He's writing the code first. I'm not going to read the code first. I want to read his English. This solution automatically tracks line numbers using a separate thread. To use it, just wrap your main client code with the tracker initialization. Let's see what he got here. So we have class dynamic line tracker threading thread. And it's a file. Okay. So we have a class here. We have the initializer. And this is a subclass of threading.thread. Now I'm not sure. I'm not sure that this is exactly what I would want to do. I don't need to create a subclass. Target thread. Let's just see. Let's let him cook. All right. Let's let him cook and see what he's cooking here. Save file. Current line 0. Running true. Damage true. Okay. While self running in self target thread is alive. While self running in self. So we have our target thread. So the target thread is going to be like the main thread that we're tracking. Okay, I see. Okay. Okay. I don't know why this couldn't just be a function. Like, why does this have to be a subclass of threading.thread? I'm not sure. Maybe that's required, but I'm not understanding why this is necessary. So we have, okay, frame, and this is what I was thinking. This was something that involved using the frame, the stack to get this information. So we have run. It says while self running and self target thread is alive. Frame equals sys current frame get self target thread ident. I don't know what ident is. See, this was I didn't know how to do this. I didn't know how to interact with another thread and get that thread's information. So apparently you can do that if Claude is right using the sys.current frames. So I guess a thread is considered a frame, like, or something like that. And I need to understand a little bit better of what a frame, like I kind of know what a frame is. A frame is composed of stacks, right? Is that right? Is a frame composed of stacks? So we'll say, let me prepare this. One, is a frame composed of stacks? Can, is it directly related to the OS? Can you explain that, what it is using a visual example relative to other components? And then we have 2, which is, what are we at? Where are we at here? Is a frame composed of stacks? Yeah. It is a thread a separate. Explain this a bit further, and then what do we have third? So let's see. So a frame says current frames get self target thread ident. 3, what is ident? Ident. And then do we have number 4? If frame. So it says frame equals syscurrent frames get target thread dot ident. I don't know what that means. If frame current line equals frame dot f line now. And then okay, so that's what I need to know. Say 4, will the line that runs detect which line the target thread is on, is running, is actively running at any particular moment? Will it be able to accomplish this with solid accuracy? With adequate accuracy? Let's see. So then we have self.save state. So then it basically saves the self-save state. Where is it? It's a running self-save state. So it's basically saving. Okay, here we go. Save state. Time sleep to reduce CPU usage. I don't know why that would reduce. I don't understand. Because we want it to constantly run. We wouldn't do the sleep. So def save state with open save file based on dump. So it's basically saving that line number to the save file. Okay. And then we have def get last line. Where's get last line at? So get last line. Okay, so that would just load the last line from the save file. Okay, cool. Then we have main while loop. Last line equals get last line. If last line is greater than 0, 0 from last line. Tracker dynamic line tracker threading. Got current thread. Oh. Wait. Why would we do tracker equals dynamic line tracker? Threading that current thread. I don't think that's how that works. Is Claude mistaken? Is Claude hallucinating here, or is that me being wrong? Let me ask about that. 5. This code would it need or rather, this is a syntax. Is it proper syntax to pass the current thread object to dynamic tracker? Or are you hallucinating? And it actually has been shown that asking if an AI is hallucinating will help it not to hallucinate, or to tell it in your prompt to not hallucinate will result in it not hallucinating and giving you more accurate answers. That's actually, like, as far as I've been informed, a true statement. Or am I wrong in my understanding of proper syntax here? I thought we would define it as a subclass of threading.thread. Like, when we made it a subclass, but not that we would pass in actual thread object. You see where tracker is dynamic line tracker. No. I'm just like, wouldn't, do you mean instead that, don't you mean that we would instead create a function, not a subclass, that took the current thread as an argument? Wouldn't that be more proper? Or is there a reason you did it this way? And this is probably the most extensive set of questions and complex question that I've ever presented to an AI, honestly. But I have to use the restroom, so I'm gonna have to take my break. I'm 6 minutes off on my break, so I'm just gonna actually pause my timer, and I'm gonna go take my little break. I'll be back shortly. I'll be right back. Use the Okay, I'm actually not gonna take my break right now. I just had to piss, and I kind of wanna see this answer that it gives me. I'm really curious to see what sort of answer we're gonna get here, and I'm excited because I feel like I'm making progress with this problem that I've been hung up on for a while in my mind. As far as this, you know, it's really important to figure out a solution to this. Anyway, so this code is good. What Claude presented with overall, but I'm finished looking at this. So we have the main client loop, last line equals get last line. If last line is greater than 0, resuming from last line. Tracker equals dynamic line tracker. This is the part I don't understand. We're saying tracker equals dynamic line tracker. He's calling this like a function, you know? But it's not a function. Am I not understanding this correctly? Because it seems like what he should be doing is making this a function, not a class. We have class dynamic line tracker, and it's a subclass of threading.thread. And like I don't know why he's doing it like this. Like, why do we? Okay. Oh, no. Okay, I'm wrong here. I'm wrong. Okay, I see. All right, I'm an idiot. I'm an idiot. I'm a little sleepy here, right? I'm a little rusty, a little sleepy. He's passing in the target thread argument. So the target, yeah, because this is the initializer, right? He's passing in the current thread. Yeah, it's passing in the current thread. Okay. It has nothing to do with being a subclass. So this, I get what he's doing here. I got you, bro. He's right. I was wrong. So target thread, right? Okay. Threading that current thread, and then tracker start. If we do tracker start, where's tracker? What does he get this from? Okay, so start. Tracker is the starting of that tracker thread, right? Okay. And so let me just review real quick. Import sys, import threading, import inspect, import time, import JSON, class dynamic line tracker, subclass of threading thread, initializer takes self, target thread, save file equals line state JSON, super init to get the subclass initializer run, self target thread is equal to target thread arg that he passes in, which is the current thread that he passes in as the arg lower down. Self save file equals save file, which he defaults to line state JSON. Current line starts at 0, running is true, daemon is true. Okay, this is all good. Then we have run, which takes self while self running, and this is a thread. So he's while self running, he's just modifying it, right? This is what a subclass is saying. Methods. He's modifying the parent class method run to do self running, and self target thread is alive. So while they're both alive and running, then frame is equal to sys current frames get target thread ident. Now, I don't know what ident is, that's why I asked him. And then if frame, which obviously it contains certain information about the frame, and then so if frame is not equal to none, then fucking stupid thing. Self current line equals f frame f line now, which gets the line number, right, of that target thread. Okay. Then we save it using save state function sleep. We don't need to worry about that. At least I don't think. So then we have the save state function, which takes self with open self save file w right for write as f JSON dump line self current line to the file. So you're saving to the file. Then we have stop, change self running. Okay. Get last line, which is a function defined at the base level. So it's a file function, not a class function. Then we have try with open line state JSON read as f, return JSON load f at line of E in dictionary, except file not found, error JSON decoded error, return 0 in that case. So then we have the main client loop file function, last line equals get last line, easy. Skip last line position if the last line is greater than 0, resume from last line. So then we start the tracker. We hit our break time, so we're about to take a break. Tracker equals dynamic line tracker, threading current thread. Tracker equals dynamic line tracker, threading current thread. Tracker start, alright. So you're creating a new thread object instance, passing in the current thread as the target thread arg, which is going to be used to check if it's alive, and which is also going to be used to get the target thread's information, which will contain its line number. I'm guessing that means what it's currently at. Then we're starting that thread, right? So now we have two threads, and then we do try while true if some condition, your reconnection logic. Then current line equals tracker.current line, disconnected at current line. Okay, and then finally tracker stop. Okay, so that seems good, right? Like that seems really good. That I just didn't know that you could do that. I didn't know that you could just keep track of where the thread is at. I didn't know, you know, but I mean traceback does that, and I'm guessing the traceback, and that's what I want to ask, is this line number tracking method similar to how traceback print out know which line an error happened at? Okay, so we'll roll with this set of questions, and I don't know if he'll answer all those questions at once. Okay, he drew this for me. So I wrote, I have one, is a frame composed of stacks? Is it directly related to the OS? Can you explain what it is using a visual example relative to other components? Okay, so here we have one. A frame is a data structure holding execution context, local variables, line number, and code being executed. Each function call creates a new frame. Right, so a stack is composed of frames, right? It's the other way. It's not a frame is composed of stacks. A stack is composed of frames. Like, a stack is a stack of frames. Just like a stack of plates, where the plate is a frame. Each function call creates a new frame. The OS manages process memory, but frames are Python level constructs. Okay. So each thread has its own independent stack of frames. Each thread has its own stack. Got it. So when we say current frames get self-target thread, I guess current frames includes frames from other stacks. It must, or unless they got that wrong. Each thread has its own independent stack of frames when functions are called in a thread. Let me ask that. So does sys current frames that get? So since each thread has its own stack, that means accesses frames that are in other stacks as well. Let's see. So each thread has its own independent stack of frames. When functions are called in a thread, new frames are pushed onto the thread's stack. Ident is a unique identifier, thread ID, assigned by the OS to each thread. So that's ID. ID. Int. ID int. Identify. Duh. Identifier. Identifier. Thread ID. So this is getting the ID of the target thread, and then if that frame is not equal to none, then self current line equals frame, which is using that identifier ultimately. Frame dot f line. So it's getting the target, thread using the identifier. So this is returning that frame, and then we're getting the frames dot f line node to get the actual line number for that frame. I understand. Yes, frame f accurately reflects the currently executing line in target thread. It's the same mechanism Python uses internally for tracebacks. Fucking right. And it says 5 exactly. Tracebacks in this line tracking use the same underlying frame inspection mechanism in Python's C implementation. That is cool. This is really cool. I love it. It's really cool. This is why I like programming. I like this sort of thing. How to do this. This is great. Okay, so cool, wonderful. I understand. I just want to clarify this. Yes, syscurrent frames returns a dictionary of all frames from all threads in the current process, with thread IDs as keys. That's why we use get target thread ident to access the frame from a specific thread stack. The thread code can peek into other threads stacks without affecting their execution. Gotcha. So let me look at this diagram here. So we have the process, main thread, line tracker thread, then we have a stack for each one. Then we have frame, earlier frame, local variables, line and code object. Great, this is awesome. This is return dictionary of all frame threads in the current process with the IDs as keys. This is what we use. Okay, so I actually was supposed to go take my break. Um, so I'll go do that. I'm starting to get a little bit tired here. I'm probably gonna go to the gym, actually. Um, yeah, I think I'm actually gonna go to the gym here. So I don't think I'm gonna take like a 5-minute break. I'm probably gonna take like my hour break, whatever. And I'm gonna go to the gym and wake myself back up here. Some more coffee, some shake, coffee, whatever you want to call it. I'm gonna go a couple more minutes here though to finish up this little section. Okay, so this is a critical. Actually, you know, I've never really done this before. I've never actually just copied code straight up from but I'm really just gonna copy this code. We're gonna make a new file here, and we're gonna just call it AI Claude line tracker solution. Alright, we're going to paste that code. What? Yeah. Just gonna paste that code in and have it. And we're gonna save this. So AI did some work for me here and did a really good job. I didn't know you could do this, you know. AI is great for this sort of thing. Really great for like mid-level learning, like I'm doing. You know, not it's good for base level learning too, but it's also good for mid-level. At a certain level, it just can't. I don't think it at that, but mid-level, low-level stuff, it's really efficient. Can't be wrong. You just, you know, you have to back with it and learn from it. Dictate exactly what code to use. Yeah, so this is great. We're gonna use this exact concept. This is a perfect solution. So I'll just write this here. Things to do. We'll write entry system. What seems designed to for exact display is essential rather than exactly when DC that. This could become very time stamping. Whenever tracking similar hard to use back. Solution found. C main slash AI Claude line solution, whatever, something like that. Uses same mechanism that trace back uses. Awesome. So basically, yeah, now we're gonna be able to know exactly what line we broke off at, and that means, okay, well that doesn't, now, okay, here's another question. We'll put next question, Claude, or AI. Is there a way to jump back into a function at a particular line using the saved line number? That's what we need to know. Is there a way to jump back into a function at a particular line using saved line number? So let's ask that, and then I'm gonna take the break. I just want to see what he says. Yes, current. Nope. No, Python doesn't support jumping to arbitrary lines within a function. The save line number is useful for tracking position, but can be used to resume execution at that point. You need to implement implement your own state machine or checkpoint system. State machine or checkpoint system. What does that mean? State machine. State machine or checkpoint system. And this is like the two worlds I was talking about, right? We have, well, actually, to handle zooming from specific points in your code logic, you're using a state variable and conditionals. If state is one steps 1 through 3, go to step 4. Right, gotcha. So we could use the line number tracking to assign state. Right? Could we do that? Could we use line number tracking to assign state for jumping back into main while using proper state initialized functional code as so yeah, like we could, and this is the exact thing I was talking about compartmentalizing or modularizing, functionalizing, whatever you want to call it, dividing up the code into various steps, and like basically, yeah, like we said, the work has to be done. So we have to assign at what point would we consider it the next state, you know? It wouldn't be directly correlated to each line. Obviously, because then you would have to have each line in a function, and that's not going to happen. This isn't true line level resumption, but achieves similar functionality through explicit state management. Are there other ways to accomplish this goal? There are other ways to accomplish this goal. Here's some alternative approaches to track and resume client state. Let's see what they got to say here. This is good. Number of checkpoints in your code. Do work, save checkpoint, do work, save checkpoint. Right, okay, straightforward. And then we have event state machine. States is init, connecting, processing, disconnected. Ah, now this is good. This state equals load state. While true, next state equals state's current state. Okay, right. So these are like the two different worlds I was talking about, basically, where one of them is more about checkpointing, and the other one is more about like the concepts, the different processes, and like, have we finished initializing? If we haven't finished initializing, then basically like redo the whole initialization process. Are we connecting? If we're connecting, don't worry about exactly what part of connecting we were at. Redo the connecting. Start from the beginning of that process. Processing, like, were we processing some data? Don't worry about what part of the processing we were at. Just go ahead and redo the entire processing process. Were we in the state of being disconnected? You know what I'm saying? So like, this though does require like intelligence, obviously, to all of them do. This one would require, I feel like this state thing is smarter. I don't necessarily know why. It's not smarter per se. It seems like it would be less code over. You know what I'm saying? Like, not necessarily. That's not necessarily true. It's basically the same thing as a checkpoint, though, when you think about it this way. When you think about it as doing work and then having a save checkpoint, this is basically a state. And then this is basically, every checkpoint is just a new state. So it's really just like expressing the same information in a different way. Now, it is a little more explicit in like understanding. Instead of you're looking at checkpoint numbers, you're looking at a concept or a process, like processing, using whatever. And you need to, obviously, when you have like data transfer going on, you know, either way, like either if we use this method or the checkpoint method, we still are going to have to intelligently determine what data to use. You know what I mean? Like, what data are we gonna have to resend get something resent? Are we gonna be able to determine if data that was received is in our system and just needs to be processed, like, or is the fact that it has been partially processed going to hinder our ability to successfully process it, you know? Or like, do we need to throw it away and restart the process? You know, there's either way, we're gonna have to put in some work. Ideally, I would like to add all of this code that I'm proposing, like that I'm talking about right here, in we would like to do it in a different location, separate from the client files, from the client file. I don't want to add a bunch of code to the client file. They're already kind of complicated and messy, and I would prefer to have this in its own file or thread at least a thread, preferably a file that like creates a thread, something like that. Anyway, and then let's look at the third option, message queue with persistence. So we have client queue is load queue state, while true, message equals queue get, process message. The event state machine approach is generally most maintainable for complex client server applications. Can you elaborate a bit more on each topic you made? I would like to understand a little bit further. Okay, let's see what he says here. Key difference between these approaches: checkpoint system is simple to implement, good for linear progression, limited flexibility for complex state. Best for games apps with clear progression points. State machine, most flexible and maintainable. I don't understand why is that? Handles complex state transitions. Okay, yeah. All right. Okay. Like if you're going from connect to disconnect, or from process to disconnect, or from, you know what I'm saying, to disconnect to connect, like there's different behavior. Okay, I get that. That makes sense to me. Okay. Yeah. Clear separation of concerns, right? Best for networked applications. I mean, right, like that's seems. Message queue ensures no work is lost. Good for async processing. Ensures no work is lost. What does it mean exactly? No work is lost. No work is lost. Good for async processing. Built-in retry capability. Best for message-based systems. Each method has different persistent strategies. Checkpoints, JSON files for simple data. State machine structured state files. Q, pickle files for complex objects. Can you explain the Q method a bit further? Well, I don't really understand. The Q method acts like a persistent task list. Functions import deck, import pickle, persistent Q. Double to Q for efficient. State file equals Q pickle, add message. Q append the message. Get next to documents equals. Okay. Okay, I don't. Messages survive, crashes, failed operations can be retried, processing order is maintained, efficient add remove operations. Yeah, that's. I'm trying to make the shoe fit, and I'm just, for this application, I don't think the shoe is fitting. You know what I mean? Yeah, the shoe is not fitting here, dude. No. Yeah, that's. No. Okay. Anyway, we're throwing that away. So yeah, it's between the first two. It's between the checkpoint versus the event or state machine. We have game state machine from enum, import enum from data classes, import data class. Class game state enum. And class game context. I don't know what add data class does. Player data dict object. Player data dict. Connection object. Game state machine. State file. Game state JSON. Handlers. Game state init. Self handle init. Not connecting. Handling game. Handle disconnected. Handle init. Initializing game. Context.player data equals load player data. Return game state connecting. Handle connecting. Okay. Let's see. I get what's going on here. These are basically checkpoints. It's in the form of states. Instead of 1 2 3 4 5 6 7 8, it's 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. This makes sense to me. Connecting self extract text connection, establish connection, return game state in game. context is establish connection. Yeah, so he doesn't really. It doesn't. Um, let's see. Nope. Save state. No, 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 no. I got lost. Where are we? Handle init, handle connecting, handling game. So and it says return game state in game, which returns this function. Okay. Try process. Okay, and then when you get a connection error, you return game state disconnected. Okay, so that's good. I like that. Handle in game self context. Try process game loop. Passing in context. Handle in game context. I'm not. This is game loop. Okay. This is. I see. This I think may fit with how I have it structured. I think maybe the checkpoint system would probably be most appropriate to not require having to refactor. I think the state system here is more optimized, but I really want to refactor my code, you know what I mean? And as far as like a context, I'm not sure exactly how we would articulate context. You know what I mean? Because context here is very complicated. Process game loop, because this is a rigid function that takes in dynamic context, but we have a very dynamic set of code. Like, it's just not structured that way. You know what I mean? Like, this is a kind of a completely different design philosophy than our design implementation. We have self-save state, game state, in-game context. Return game state in this game. So then you're do more handling game and you have more context, right? Like, I get what's going on here. I get that. That is. This is a thing. I'm understanding this is a thing, but I'm not seeing that we could implement that thing easily. I think that the checkpoint system is probably easier to implement with our current code structure. And we don't necessarily have to use numbers. We could use strings, which would act as states. You know what I mean? We could just have, or a dictionary that associates the int with a string state. We could figure out how exactly to do that. But it looks like the checkpoint system would be quite smart. I don't know though. I don't know. Well, the way that they implemented this state system, I could visualize implementing it in a little bit of a different way, which is basically like the world in which we have the data. Like when we re-enter, we have a quote-unquote reconnect protocol, and that's based off of like the state and all that. Like basically, you know, if we were processing data, would data, you know, just making sure everything is done correctly. I know that's a very generalized statement, but if I were to make it specific, I would have to be specific on a lot of different things. So, yeah, my brain's starting to hurt a little bit. I'm gonna go ahead and take a break. We're gonna go work out. It's heavy bag day. Is it heavy bag day today? Well, actually, what's today? Today's Tuesday. Or today's Monday. God. I'm bad. Sorry. Sorry. Yeah. It's definitely Monday. When it's Monday and you're thinking it's Tuesday, it's definitely Monday. You know, you have a case of the Mondays when you got your Mondays mixed up with Tuesdays. Dude, like the past 3 weeks, I've worked so much, and like my schedule, my work schedule, and like which days am I off of work, which day am I driving, which day am I working preload, which day am I doing both. There's different pay for each different task. It's really hard. It's not really hard, but it's I'm used to just working preload, going in at this time, getting off at this time, working 5 days a week, and then driving on Saturday. But peak season is completely different. It's completely hectic. Sometimes you work preload and then you drive. Sometimes you just drive, and then you're still working Saturdays unless you have worked too many hours, in which you can't work Saturday. Like there's a lot of different little factors that you have to keep track of, and I've just been really busy keeping track of the dates and the day together has proven to be a difficult task for me. Like the past 2 weeks, I'm like, dude, I don't even know what day it is. And if I know what day of the week it is, I probably don't know what day of the month it is. And if I know what day of the month it is, I probably don't know what the day of the week is. It's like I can only seem to keep track of one or the other. Um, and I just wanted to clarify this, right? Because I thought we had this wrong on my work calendar. Yeah, they put Wednesday as New Year's Eve. Yeah, Wednesday is New Year's Day. We have to work New Year's Eve, but we're off New Year's Day. So we work New Year's Eve, we get New Year's Eve night off, and then we're off New Year's Day. Wednesday, so I have to work tomorrow. Yeah, anyway, I'm just like reminding myself I gotta go in at 6:30, which is later than normal, but I get to drive tomorrow. We're doing air only, so it's air driver pay. So I'm probably gonna do preload and air driving, which should be no problem. Okay, all right. I'm going. I'm gonna work out. I'll be back.